Good morning, year 10s. Hey guys, thanks for coming. I got 2 people waiting on the video now. If anybody, I think some people might be struggling to find the video. So I can try share. If I go copy link, I can lob that link. Struggling to find the video. So hello. Let's get rid of that. Winner, that's better. Right, I'll lob that onto our chat. There you go, guys. Here's the paste. Oh, got no enter. Lol. Enter. Oh, it's making me go the wrong way around here. Oh no. My key. Oh, there we go. Keyboard's back. Oh, no. There you go. There's my YouTube video, guys. Right. What I'm now going to do is, hello. Hey guys, 6 people watching now. It's great. Right. I'm going to share screen immediately. Let's crack on. I've got you guys on the chat, which is amazing. Let's see if I can find all my chat windows and stuff. There it is. I got it. I wonder if I can close that down and keep the chat. Can I keep the chat open? I can. Oh my God, that's awesome. My chat is still running, but I've managed to close down my YouTube bit, which is amazing. It's even better. Right, let's go back to this and we'll crack on. Right, okay guys, so today's lesson is on rusting. So it's only going to be a short lesson, just 25 minutes. So today's title is rusting. So 4 learning objectives, know why rusting is special. Number 2, know what's needed for rusting and the practical, which I'm going to mention in a bit. Number 3, understand prevention methods. And the last one is understanding galvanizing. Cool. Okay. So I thought I'd get a whole load of cool pictures. And I think pretty much everybody tends to recognize the word rust. I don't quite know whereabouts rusting comes from in kind of an age-wise and whether or not it's from your parents. But rusting is a very special process, and there is only, and this is an important note to Bene, so we can make some notes. I've got another beautiful picture of rusting. Isn't that pretty? Look at that. Isn't that pretty? So let's make some notes. And I'm going to work so rust actually has a very distinct color. I'm suddenly realizing what I can now do is disable my camera again, because if I disable my camera, everything runs a little bit more smoothly. There we go. That's fab. Right, so rusting. Oh, I'm not going to write in that color today. I'm going to write in a rusty color. Yeah, there we go, rusting. Because rusting, so first off, we need to talk about facts here, guys. Facts. So fact number one, only, now notice my capitalization, only iron rusts. No, now I do now need to put a little clause on this. I am also going to say, oh yeah, and steel. Yeah, but this isn't really fair. Yeah, the reason being is steel is an alloy. So I'm just going to make a note of that, and steel. So steel is a mixture. Now, by the way, when you have a mixture of metals, steel is a mixture of iron and carbon. Yeah, it's about, depending on the type of steel you had, and I'll do a lesson on steels. Yeah, it's about 95% iron and 5% carbon. Yeah, this is actually called high carbon steel. But steel also rusts as well because it contains iron. But you must have iron for rusting. Yeah, so fact number 1, only iron rusts. So fact number 2, so hang on a minute, I'm going to change my color now because this isn't rust. Yeah, so if we go to a different color, let's go for gray for other metals. Number 2, all other metals, except for the noble metals like silver, actually silver does, gold and platinum, all other metals corrode. Now that is not corrode. It's not the same thing as rusting. Let me show you why. Because you can see that rusting is very special. Rusting does an awful lot of damage to iron. And the reason what makes it special is because when it forms, it then will break off. Can you see the big holes in this ship? Yeah, if I switch back to my iron color, which I've now lost. Oh, I haven't, there is. These holes are caused, yeah, by the rusting eating away at the metal. Yeah, and that's very unusual. If you look at corrosion, here's what corrosion looks like. So this is aluminium. Yeah, so this is aluminium metal. And this is aluminium corrosion. Al corrosion. Now, what you're actually forming, just so you know, is aluminium oxide. Al2O3, aluminium oxide. And aluminium oxide is white, but it's not quite the same. It's not as damaging. It's not. You see, the reason why rusting is special is because it flakes away and it exposes more iron, and eventually the whole thing falls apart entirely. So rusting is special because of the process of how it eats it. Yeah. So only iron rust, all other metals corrode. Going to switch back to rusting. Okay, number 3. So what is rust? Rust is iron 3 oxide. Rust is iron 3 oxide. I like it. So if you had iron 2, so I mentioned this to Lauren earlier in the lesson, iron 2 is green, whereas iron 3 is yellow or brown. And in this case, it's brown. Yeah, you can actually see the yellow and brown bits. You can see the 2 different colors. Yeah, but the rust is iron 3 oxide, and that number is needed. You can't call it iron 2 oxide because it's not. Iron 2 oxide simply becomes iron 3 oxide. Steel contains iron. Yes, that's correct, Ian, it does. Yeah, absolutely right. I haven't copied them. Yes, please. It's in the description. Just found it. Thanks, Jack. Welcome. Steel contains iron. Okay, Ian, great. Yes, steel does contain iron. All steels do. Okay, so now that we've got rust is iron 3 oxide, we can do fact number 4. Okay, so what is needed for rusting? Yeah, so we're just basing this lesson based on, so number 1, know why rusting is special. Yeah, so we know why rusting is special. 1 is because only iron does it. And number 2, because it eats away at the iron metal and causes damage. Whereas corrosion doesn't quite do the same thing. It's simply like damage to the surface, whereas rusting eats away at iron. Yeah, okay, so what do you need for rusting? So this is where I come across the practical to do this. So we would have done this in class and just set it up at the back and left it for a month. So you'll notice that I've got 3 test tubes here. And I've got a test tube with water and a nail in it. And you can see that the water in the nail has rusted. Look at the next tube. The next tube, I've put water, which has been boiled, yeah, and oil on the surface. And the nail has not rusted. This one has rusted. Rust. This one, no rust. Yeah. And the last one is in anhydrous calcium chloride. And no rust. So the question is, what do you need based upon this observation? What things do we need for rusting to happen? And you can post this on the chat if you like, guys. What do you need based on this information? What do you need for rusting to happen? And I'll give you a clue. There are 3 things needed. So let's write that down in our notes. So number 4. 3 things needed for rusting. Number 1, water, oxygen. Yeah, so we've got water. Yep. We need oxygen. Yep. We need one more thing. No bacteria. Nope. Good effort, though. Good effort, Owen. Good effort. The other one, you're going to laugh. I love that no one's put it. Yes, Masaru! Nailed it. It's iron. Hey, you need iron. These 3 things you need for rusting to happen. So the question now is, if we need these 3 things, how can we now protect against it? So fact number 5, protecting against rust. Right, so let's have a look at some objects, which this is where it would have been useful if I'd pre-done this, but I don't really need to. I can do this anyway. Oh, my laptop's doing something funky because it's on the other screen. I can fix that. I can fix it. There we go. Okay, so let's go for car body. So guys, on a car bodies are made out of steel. Yeah, except for the sports cars, they're different. But most car bodies are made out of steel. So what do we do to protect the steel with a car body. What do we do? How are we protecting this one? I'm going to go back to my chat. I've lost my chat. Oh no, I've lost my mouse. I've lost my mouse. Where's my chat? There's my chat. So guys, English, lol. So what have they done to the car body, which is made out of steel? What have they done to it to protect it from rusting? I wonder how long it'll take people to figure that one out. Protecting against rust. Number one. Anybody? Paint. Love it. Number one, paint it. Yeah. So paint does two things. Add a protective coat, like paint. That's correct. Well done, guys, on the chat. So paint protects metal from water and oxygen. It prevents both. It's adding this layer, this sealed layer. Right, next picture. Next picture. Bicycle, bicycle, bicycle. I want to ride my bicycle. I'm sorry, what? Bicycle chain. Right, how do you protect a bicycle chain, yeah, from rusting? Because the problem is we know that they rust. I think everyone here, I'm be very surprised if I don't find just a, there we go. So guys, here's an example of a bicycle chain that's rusted. Can you paint a bicycle chain? I like it. It's already on the thing, oil. I like it. So number two, oil. Now oil, not good for a car body because it's gonna wash off in the rain, so it paints better. But for a moving object, moving objects, yeah, oil for moving objects. That's all we need to put. Okay, next, how else could you protect against rusting? Let's go for the next one. Let's go for the next one. Yeah. Let's go for outdoor bin. So outdoor bins, oh darn it, it's kind of not what I'm looking for, really, to be fair. No, I don't want that. They painted them. All right, fine. Outdoor bin, make them out of plastic. Outdoor bin, metal, not, yeah, you get the point. Yeah, there you go. Okay. So, how do we protect these guys from rusting? Now, the reason why you can't paint dustbins. Now you're going to say, but they do. I know they do. I know, but it's not really a very good idea. Yeah, the reason being is because bins are being bashed around. It's different if they're bolted to the floor, then you'll paint them. But bins that are being moved around, yeah, if they're made out of metal, you can't just paint them because the paint will just get chipped, which means the water and oxygen get in, and then rusting happens underneath the paint, and then all the paint flakes off. You've probably all seen that. I'm going to put rust paint flake. Let's have a look at that one. Images. Yeah, flaking paint. This is what happens. Once you chip the paint, the rusting gets underneath the paint, and then it eats all the metal underneath the paint. Yeah, it's a nightmare. So what we're going to do, we do something else. So you guys will have all seen these bins. Yeah, now that metal is a rather, put them in a vacuum. Oh my goodness. So can everyone now point and laugh at Masaru? Because apparently he's going to send his bin to space. Masaru, it's really difficult to put things in a bin when it's in space. Just throwing it out there. Yeah, so what we're actually going to do is we're going to cover it in another metal. It's called galvanize. Dun, 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 that's a song called Galvanize, by the way, which is otherwise known as cover in zinc. So we actually cover steel objects in zinc. The reason being is zinc is a more reactive metal than iron, so even if it gets chipped, which it can do, it actually takes the oxygen over the iron does. It's really clever, actually. So we can galvanize, which is to cover an object in zinc. And the examples for that are like bins. That's a really good example. You can always tell galvanized metals because they have a rather beautiful crystal-like structure. I'll show you. Galba, don't know what Galba is. galvanize metal images. So if you actually have a look at anything that's galvanized, you can always tell when it's covered in zinc because you can see crystals of zinc. Isn't that beautiful? And zinc is a bluish metal. Oh, look, check that out. Hot dipped, look at that. Oh, look at that. So hot dipped and normal galvanized, they're both galvanized, by the way. Difference between galvanized and hot dip galvanized, same thing. Yeah, but when you do hot dip, they put it into hot metal and it forms the metal surface. It's just dipping it in liquid metal. It's kind of cool. It's kind of cool. You put the trash in firsthand and then send it to Elon Musk's postbox. Absolutely right. Yeah, that's a bad idea, by the way. Just not trash in space. You've got enough trash in space as it is. Okay. Now, these are the top 3 answers for protecting against rusting. However, there is a very special example, number 4, which is boats. Now, boats have a big problem. Now, this is special. This is the only time we do this, guys. Boats, number 4. This is special. So the problem is that boats are put into the sea. And the problem is the sea has got lots of water. It's got salt, which speeds up rusting. Let's make a little nota bene. Nota bene. Salt and acid can increase the rate of rusting. So if you put anything containing iron into salty water or acidic water, it'll rust more quickly. That's because the metal reacts with the acid and forms the salt and hydrogen. The hydrogen causes the rust to flake off, so then more iron's exposed, and you kind of get the picture. So boats are special because they do something very special. This is called sacrificial metal. Sacrificial metal. Sacrificial metal. I'll show you what that looks like. So what they do, they bolt. Yeah, they bolt big blocks of magnesium to the surface of the boat. Sacrificial metal. And I want to show you that this is just for boats because look what I get. The only thing you're now going to see is boats. Yeah. So this is all about boats in water. Sorry about the fact that there were loads of other pictures, but boats mainly. Yeah, there we go. So there they are. There's the sacrificial metals. They bolt bits of more reactive metal. I'm trying to find a better picture that's easier to see because it's really tiny. I want a bigger picture. There we go. And you can see the sacrificial metal blocks. Yeah, these blocks of metal. Now, what they will do is because it makes the metal impure. Well, we already have kind of stuck a lot of trash in space. Yeah, it's because it makes the element impure. No, it doesn't. No. It doesn't make the metal impure. We're just sticking it on the surface. So just to show you that, here's a panel of steel. Yeah, here's a panel of steel. Yeah, iron and carbon mix, Fe and carbon alloy. I'll put alloy. The word alloy is the word for mixture of metals. Yeah, so iron and carbon. And because this is steel, what they then do is they bolt onto it blocks of another metal. Now, they either use zinc. They can use zinc. Sometimes they use magnesium. Yeah, they bolt on these little blocks of other metals. Yeah, so bolt on. So that's just stick on. I'm just going to put zinc / magnesium blocks, either one, whichever one they have at hand. Yeah. Now, the reason being is zinc is more reactive than iron, which means it'll take the oxygen first. Yeah. So it's a rather clever trick, this. Yeah. And that's all you need to know in terms of protecting. Okay. So at this stage, and I want to come back to my practical. So if I go back to my learning objectives, right. What's needed for rusting? Done. Prevention? Done. And we've talked about galvanizing the covering in zinc. So now what I just want to do is, it's a short lesson today, I just want to focus on this practical over here. What I'd like you to do, guys, is I'd like you to, in your exercise books, you can pause the YouTube video at this point and you can draw that into your exercise books. Now, just to explain what each bit is doing. Yeah. So number one, why have they, I'm going to highlight certain bits here. Number one, why have they boiled the water? So I'm just going to put a little key over here. So why have they boiled the water? So tap water contains contains dissolved oxygen. This is why fish can live underwater. Yeah, there's oxygen in the water. It's dissolved in it. So when you boil it, boiling removes oxygen. We talked about this when we talked about the solubility of gases. So they've boiled it, removes all the oxygen. Now, what they have to now do is the oil. I'm going to color code this in green. So what's with the oil? So the oil is to prevent any more oxygen getting in. Prevents oxygen prevents oxygen getting back in, dissolving, prevents oxygen from dissolving into the water. So this is going to be from the air above it. Yeah. The next thing, right, in the next tube. So by the way, in this case, we've got iron, we've got water, but we've got no oxygen, so no rusting happens. No rust, no oxygen. Now the next one is in the next test tube, which I'll highlight in blue, we've got dry air. So we've had to make dry air. The reason being is, so I'm going to color code this as well. The dry air contains no water. No water. Now, how do you dry air? I'm going to use a different color. Anhydrous calcium chloride. So last one, and then I'm finished my lesson. Yeah, so anhydrous by the way means without water. Without water. Anhydrous calcium chloride. Calcium chloride is a drying agent. We've mentioned this before in previous lessons. Is a drying agent. So that's going to mop up any water in it. So this has no rust because there was no water. So it's a clever experiment. It allows us to prove what we need. So guys, what you can do is you can take a screenshot on your laptops of this, and I'd love you to draw that into your exercise. Alternatively, you could even just print it off and stick it into your books if you like. Is it because the element, talking about the salt? Does salt make the elements impure? The salt is in the water. Are you wondering why salt increases the rate of rusting, Zina? Is that what you're asking? Guys, this brings us to the end of the lesson. We're done. That was a lovely, speedy lesson, wasn't it? Love that. Right. What I'm going to, first of all, I'm going to do is I'm going to turn back on my camera, because I need to turn that back on, otherwise no one's going to be able to see me. Enable device. Wait for that to come back on. There we go. And then I can go back to my YouTube channel, and I can go start cam. And then it's going to give me the wrong cam. Oh, no, it's back. There we go. Look at that. I can go back to this guys. Right, guys. I hope you found it useful. Yes. So, okay. Why does the salt increase rusting? That's actually a really tricky question, Zina. Okay. So in reality, it's probably because one of the reasons why rusting is special is because iron oxide, which is the orangey brown solid, is slightly soluble. It can dissolve in water. What that means is as the layer forms, it can get washed off. See, aluminium doesn't rust because it forms aluminium oxide. Aluminium oxide is completely insoluble. So it just remains there, protecting it against the water and the oxygen. Whereas the iron oxide is slightly soluble. Now, you don't want to write this down on your exam. And the salt actually increases its solubility. What that means is it speeds up the rate at which the rust breaks off. I hope that helps. Right, guys, I'll see you all next lesson. See you later, guys. In terms of homework, I don't think I'm going to give you any homework today. You guys have got questions on the classroom to do practicing for your test. We're not far off the test. Somebody asked me when it will be. It's going to be in a couple of lessons' time, so just bear that in mind. All right, guys, I'll see you soon.